Hi, welcome to Fishing Entrepreneurs. Um, Today is a bit of a special edition, really. What I wanted to do was show you, for those out there that got dreams or visions of setting up and working within the tackle industry, how you could set up a business literally in 24 hours and start making money. Um, Utilizing the technology which is 3D printing. So what I'm going to walk you through today is everything that you need to get set up, show you the costs involved, and I think you'll be quite shocked at how cheaply you can get set up and how quickly you can actually start making money. I believe you, with the right marketing, you can be in profit within 7 days. So let's go right into it. So, one of the first things you're going to have to buy is a good set of vernier calipers. It's no good trying to guesstimate the size of things that you're going to create. It just doesn't work like that. So, you need a good set of vernier calipers. So, it allows you to accurately measure the diameter of stuff and the lengths and etc. So, that's your first thing. The next thing you're going to need is a 3D printer, and the first 3D printer I ever got was the Ender 3 by Creality, and that's why I'm recommending that you do the same. I knew nothing about 3D printing 2 years ago, and it's a really popular printer, so there's lots of resources out there, forums, Facebook groups, and everyone, the whole community is very helpful. So I would highly recommend the Ender 3. The quality it produces is unreal for the money, and you're looking at between 200 and 230 pounds for for an Ender 3, which is fantastic value for money and dead easy to set up. So yeah, that's what I recommend as your starting point. Plus, if you get really busy, then you can just buy more and more machines, and they don't cost the earth. So that's what I recommend. Next thing you're going to need is material to print with. So the most typical material to use is PLA. That is what most newbies start using with, and most people have been using it a long time. It prints lovely, quality is great. It's got a low melting temperature, so prints just come out really nice. So I'd highly recommend getting a spool of that. However, it's not gonna be any good if you're gonna be using it outdoors, or it's gonna be exposed to a lot of UV on a windowsill or whatever. So in that instance, you want to go for PETG. For production parts, I would always choose PETG over PLA. PLA is great for just getting a quick print off, see what the product looks like. PETG, it's got a lot of properties of ABS. Um, it's a higher melting point, and it doesn't distort like PLA when it's exposed to sort of outdoor use. Um, so that's definitely what I would recommend. Your production parts are made out of. Now, one thing to note is setting it up and getting the temperatures right initially can be a little bit more tricky compared to PLA. However, once you've got it set up, you're up and running. So then you look at ABS. ABS is a different animal altogether. It gives off horrible fumes. Excuse me. And it's dead sensitive to ambient temperature. So if someone opens the door on you, even if you're in the house, it'll start warping and bending off the build plate. And then last but not least, TPU Flex, which is basically rubberized material, so flexibles. Fantastic material. However, again, a little bit tricky, but we'll cover that in the video series, all of those materials, printing with them. But definitely PETG, that's the spools that you want to be getting, and get a spool of PLA just for when you first start out. Right, so the next thing you want to be looking at is the software. So Fusion 360, if you Google Fusion 360 and click on the Autodesk link to that, you can actually download it free of charge. Download the trial first, and then it will give you like a hobbyist. You can sign up for like a hobbyist license, and it's free, I think, for 2 years. So sign up for that. It's the best program to use. There's loads of resources on how to use it on YouTube, forums, you name it. If you get stuck, help's out there, and it is very easy to use. So we're into the program now. What we're going to do is, if you look, it opens up in design view. So what we're actually going to do now is we're going to let's create a pole alignment bush. I can't remember the exact name for it, but basically that goes into your number 2 section. So first of all, you click on create at the top there, and then click on the bottom pane there. That's where you're going to start drawing from. So if you look at that, whichever pane I go on, I select, that's where it's gonna start drawing at the angle that it's on. So always choose the bottom one, I do. So then it's going to open up a whole host of other options, drawing options. So we'll choose the circle initially for this product because it's a little bush. So then we'll just click on the pane, and then we'll open it up. Now you can size it with the mouse like that, or which is more accurate, you can just type in the diameter and then just press enter. As you can see there, you've now drawn a circle. So we want to give that some, if I extrude that, then it's going to be solid, and I don't want it to be solid because the pole elastic's got to go through it. So we want to hollow it out. So if we click on offset and then click it, you can see it's put an outline on the outside. So you just click on that button at the bottom there, and then it turns it to the offset on the inside, and then I choose how thick I want it. So I'll just change that now to what I want it to be. There you go, and then just click OK. Whoops, just lost it there. So yeah, click OK. So now I've got the general shape that I want. So now I can either close the sketch profile, so then it puts it onto the pane, as you can see. But then what I want to do is I want to push pull that. So if I click modify, push pull, I could just press the Q button on the keyboard and it will launch it straight away. But we've just done it manually there. So then I select the part that I want to push pull, so I click it, and then I can drag it up with the mouse to whatever depth I want. And it's the same as when you're doing the circle, you can actually type in the amount that you want, so it's dead accurate. But in this instance, doing it by the mouse is fine. So you don't want this, because it's going into the pole section, you don't want this to be too long, so we'll just adjust that, because the pole sections do taper. So there you go. You've now created a solid. You've created a what they call a body. If you go into the view mode, you can actually change it so that you can see it as a solid, or you can see it with solid and still see through it. So there you go. So now I've got that. That's now made, and we've basically made a bush. Okay. So now I want to create a top for that. Now I don't click on any of the panes, I click on top of the bush, because that's where I want to draw the top. So same again, click the circle, find the center, and then I know what the outer diameter is of the pole, so then I can just type that in there and then press enter. Right, so that's now created a drawing there, and if you click on the right hand side, that's your sort of global 3D space viewer, so you can turn the part round and see it from different angles. Okay, so now I've got a drawing on there. So now I need to push pull that. So close it out of sketch mode. Like I say, I could have just pressed Q and it would just automatically do that. So I'll press Q, select the part. So there's 3 areas that I want to extrude, which is all of them, and then I come up to what height I want. Is that a little bit too high? Yeah, maybe. Let's just change it to a little bit less. Yeah, no, that's probably too small, because what we're going to do is we're going to round those edges off. So we click OK. I'm happy with that. So now if I click on that, I can actually turn it around with a mouse and just have a look at it, and we've basically created a bung. The only problem is there's nowhere for the elastic to go through. So what we're going to do is we're going to create a hole for the elastic. So it's basically an alignment bush. So one thing to note, when you're in that global view there, then you need to come out of that before you can do anything else, and the way to come out of it is by pressing escape. And then we click the sketch button, select the pane, which is top, and then we select circle, or we can press C, which is quicker, and then we'll do that 7mm, because there's a lot of 7mm PTFE bushes available on the market, so we'll push a bush into that. So I've done that. Close sketch mode, press Q, you see it's close it, select the area. Now if I pull it down, you can see it's gone red. It's gone red because it's gone into cut mode. Yeah, and if I push it up, it's gone into join mode. Right, so there you will see the operation. So we want to cut it, so we're happy with that, so we can click OK. So now that's created a hole in my bush, in my bung, sorry, should I say. So quite happy with that. What I'm not happy with is that this is sharp edges, and you don't want that. You want to be able to put your pole on dead easy. So what we can do, just turn that round. We will then fillet that edge. Okay, fillet is a rounded edge, chamfer is like an angled edge. So if we click the actual edge there like that, and then we can pull it down manually with the mouse, or we can actually type it in. I'm quite happy with that. That seems about right. Okay, so press enter. So now we've created our own center alignment bush. Now I'm not 100% happy with it because I want to put a little relief on there, and I don't want to use too much material because it's all weight and we don't want to sort of unbalance the pole. So we're going to put a relief in there, and what it's also going to do, it's going to help it stay in. It's going to create like a little bit of a vacuum. So to do the relief, it's very simple. Just have a look round. Yeah, I'm happy with that. So we push a PTFE bush into that hole there, and that stops the elastic getting damaged. Right, so now what I want to do is I want to go back to draw. Just chamfer this edge first before we draw, because I don't want it to be a sharp edge. I want it to be a nice tight fit in the pole, and if that's a sharp edge, it's not going to be easy to fit. So we'll put a little chamfer on there, and it'll just make it a little bit easier to locate. I'll put a little chamfer on there and click OK. That's great. And then right now what we're going to do is we're going to make a relief in that thing. Now there's a number of ways that we can do this, and I'm sure that people will tell me in the comments below that there's a quicker, easier way, but for me it's just as quick to do this, but I'll be happy to hear from people that can show me a quicker way of doing it. So what I'm going to do is I've chose the bottom pane, so I'm drawing on the bottom. And then what I'm going to do, I'm actually going to come out. No, let me come out there, and then draw another line, and then go halfway. So it's going to cut. It's going to make it half the thickness there. So click OK. So you see I've just drawn that on the bottom there. Come out of sketch mode, and then I go back into pressing Q, push pull. So then I choose that outer amount, and then I can push and pull. Now if I just clicked OK on that, it would just take that material away from the bottom. I don't want to do that. So what you can do is you can choose the operation, and we'll choose new body. So it's going to create what I've extruded out is going to be a new body. So I've done that. So now if you look on the left hand side, I've got two bodies. One we've just created, and the top one which is the original part. So what we're now going to do is we're going to move that second part. I'm going to move it inwards. And get it about center. Don't have to be absolutely accurate on this, and we're just giving you an idea. So there you go. And then what we're going to do is we're going to use a modify combine command. So what that allows us to do is we can select the target body, and I can do it on the left hand side, or I can just choose it within the drawing. And then what I'm going to do is I'm going to select the tool body, which is our second part, and then I'm going to, it's set to join, so that if I clicked OK, that would join, it would all become one piece. I don't want that, I want to cut that away. So click that. Excuse me. Click OK. There you go. Now we've got a bit of a relief in there. It's going to reduce the weight of it, and it's just going to create a little bit of suction when it's pushed in there. It's just going to help it stay in. Okay. And it's going to have a little bit more flex as well, because top kits too do tend to bend slightly. So when you've got a fish on, not this time of year. Anyway, so now we just, them sharp edges, we just want to put a little chamfer on them, tiny little chamfer, just to take the sharp edges off. So we'll choose them. See, I've gone too much there, it's just warned me. And there you go. So that's about perfect. So now if you look, there you go, nice, neat. You've just created your first product. Okay, so click OK on that. And there you have it. All you need is a little PTFE, 7mm PTFE bush to push in there. You could countersink that hole so that the bush sits in nice and neat, but generally that will work. And you can choose your PETG material in whatever colour you want, and you're ready. You're now ready. We'll just name this body. Go. Just name it, just to keep things neat. Oh, I didn't click enter. Let's do that again. Okay, right, now what we want to do is we want to create an STL file. So if we go down to 3D print, oh sorry, we're going to save it first. Let's save it first. The beauty of this is everything is stored on the internet. So if you lose your computer or whatever, all your parts are still in the, what they call in the cloud, on the internet. So you have to save the drawing first before you can export it. So we're happy with that. So let's go create what they call an STL file. Okay, so we go up to the top, click 3D print. And then there's an option at the bottom. It's always normally clicked. Yeah, you see it's broken it up into vectors. So now it's ready to be exported. Untick that box at the bottom. You don't want it to go straight to your printer. Okay, so you want to create a file. Yeah, because you want to be able to slice the object. So click OK, and then it's going to ask me for a file location, so we'll just probably stick that on the desktop. Excuse me. Save. Right, now you're going to go, now you've saved that, you're now going to go into your slicing software. Right, so I've opened the slicing software. I use Simplify 3D. Now you get Cura, a piece of software called Cura. With your printer, it's pretty much the same. It's actually easier to use than this. So this is how we slice it up so that we can tell the 3D printer the coordinates of how to lay down those extruded layers onto the build plate to ultimately make your part. So we select the file, off the desktop if I can find it. I'll type it in there. There you go. So we'll select that, and then it drops it onto the build plate. Okay, now it's put it onto its side, which is not ideal, but then we need to choose the material that we're going to print with now, and also how much of it, how solid are we going to print it? Do we want it to be 100% or 20% infill? And I'll show you what that means in a bit, but basically, do you want the whole model to be solid plastic, or do you want to have lattice work on the inside, so that it still retains strength, however it's lighter and it saves material? So we're going to choose PLA just for this example, but when you choose other materials, then you set up the profiles for temperature, the bed temperature and all of that, and that information is available with the actual filament. So it'll advise you whether it wants to be 60 degrees the bed, or and the nozzle temperatures. We'll cover that in more detail. That's a whole video on its own. So basically we click OK on that. Oh, actually, no, let's just change that back to 20% infill is way enough for something like this. And then, so if I actually, let's just rename that profile and call it the material name. So now, if I actually just went prepare print now, with it orientated like that, then it's not, the outcome's not going to be good. So if we click it, you'll see immediately it's created support material. Because it's laid on its side, obviously it's got loads of overhangs, and the material can't just suspend itself in mid-air. Well, it can to a degree, it's called bridging. However, so you're going to have all that support material which you're going to have to peel off, which is time consuming, and if you look at it on the top, it's going to be a little bit messy. So what you want is you want to change the orientation of that product. Okay, so when that's the main thing you need to think about. How do I want it orientated on the bed so it will be able to 3D print in the best quality possible? So if we turn that up now 90 degrees, right, okay, it's actually minus 90 because I want it on the other side, so I'll just change that. And it disappeared out of view, but if I click center and arrange, it's then there. So it's now stood up, and that should print without any support material whatsoever. So if we double click onto the material profile, we'll just make sure we remove support material because we don't need it, because there's no major overhangs. I mean, you might have products that will need support material, but on this particular one we don't need it. So now if we go prepare to print, as you can see, no support material. That's how it's gonna make it. You can see how long it takes. You can see it's going to cost 9p per unit in material, and that's because I put the unit price for PLA. So if it's a more expensive material like carbon fibre or something like that, then you just put the material cost per kilo, and then it will automatically work out what the unit cost is. It's brilliant, really. So that's all sliced ready, and I could actually, so if I show you here, it shows you how it's built up. So now if you look at that, you can see it's not solid in the center. It's actually got lattice work in there, and that's because we said we don't want it to be solid, we want it to be 20% infill, so it's created lattice work, and that's as strong as anything for that part. So you're just wasting material and time printing out things in solids. It's very rare that you need to print something out in solid. If you notice anything made out of plastic, it generally doesn't go over 2-3 millimeters in thickness, because you will get some distortion as well. So that's now ready, and you can see how it builds each layer up. That's the print head there, and that's ready to then export to my memory card, and then I can take the memory card out, stick it in the printer and click print. Okay, so what if I wanted to make multiples of these? It's very, very easy. I can just copy and paste them, or I can go up on the menu above, and then I can just duplicate them and say, 30 copies, 50 copies, however many I can fit onto that bed. So we'll just do a load. I'm not sure how many I'll fit of these on there, so I'll just do a load to start with, click center. I can fit plenty more there, so we'll just do that. A few more. You'd be surprised, you look at the actual 3D printer, which is relatively small. It'll go on your desk, no problem, but you can actually produce quite a lot of parts in one go, small parts at least. There you go, and a few more, which take it to 58 if my calculation's right. One more for luck. There you go. So that's ready. So then what we can do is we can then click to prepare the print. Now this will take some time, because obviously it's slicing up, it's slicing up 58 times more than it was with the single, and it's got to calculate the path of the extrusion head for all of those parts. So we'll let that calculate away. What's incredible is that once you've got those temperatures right for the given material that you're going to use, that's it. You've got a profile for each one. All you got to do is draw the part, put it into the slicer, orientate it the right way or the best way so you're using minimal supports, and then print them off. And once you save it onto the memory stick, I mean, you can have multiple drawings, multiple products on your memory stick ready to go. So you don't have to do this each and every time. Once it's done, then you want to do more, then you just make sure your machine's loaded with the right material and click print, and away you go. So it's nearly there now. It's just passing some of the figures, and there you go. So it's loaded. So as you can see from there, I mean, imagine if you sold that product at even £3 each. Really useful little bung there. And if you sold them at £3 each, it's going to take 24 hours to do 58 of them. So really, if you think about it, 48 hours, you've got your initial investment back. All you've got to do is find customers, market it right, and we will cover marketing in more detail in further videos and series, but there you have it. You just save that file to your memory stick, stick it in the printer, make sure it's got material on, and click print, and there you go. Well, I hope you've enjoyed this quick insight into setting up a company utilising 3D printing technology. I hope it was an eye-opener to you. There's a misconception out there that 3D printers cost the earth. They don't. You can get a 3D printer for as little as £50. The Creality Ender 3 that I suggested in this video, for me, I'm just going off my personal experience. I'm sure there's machines that are way better, and you can spend from as little as £30 right up to, you know, a million pounds on a 3D printer. So it's a happy medium at £200. It's a bargain. It's an absolute bargain, and it is a license to print money. So I hope you got something out of this video. Like I say, in future episodes we'll cover things in more detail. They'll be exclusive on the 3D software, exclusive on the marketing side, and also we'll be talking about the actual slicing software, different materials, the pitfalls and the benefits of each individual type of material that you would use. So I hope you've enjoyed it. If you have enjoyed it and it's something that you might be interested in doing, we will be setting up an area on our website, resurrectionangling.com, where you'll be able to download for free fishing products that we've designed ourselves, and that we just haven't brought to market. We just want to make it freely available to anyone, and you could be up and running literally in 24 hours. So thanks for watching, and until next time, tight lines.